Review topic 7, ground state and excited state. Let's get right to it. Okay, ground state. In ground state, electrons have the lowest possible energy that they can. That means they are closest to the nucleus that they can be. If an electron is in an excited state, the electron has gained energy and moved to a higher energy level, further away from the nucleus. When an electron absorbs energy, it can move from ground to excited state. When electrons emit energy, they fall back from excited state to ground state. And you can see that represented in this GIF that is playing. You can see energy needed to be added to force that electron into an excited state. And as the electron fell back from excited state to ground state, it released energy. We see that energy as light. Okay, so ground states are listed on the periodic table. Here's an example with neon, so let's just look at it. On the periodic table, it says for neon's electric configuration 2-8. So 2 electrons in energy level number 1 and 8 in energy level number 2. If an electron gets excited, it will move to a higher energy level. So this represents an excited state configuration for neon because one of its electrons moved to a higher energy level. So one electron moved from the second energy level to the third energy level. Okay, so remember, on the periodic table, it's always ground states. So let's look at the periodic table for a moment, and then I can show you how to write an electron configuration in excited state. So here's our periodic table. And let's look at carbon. So carbon says 2-4. So 2-4. Well, that is carbon in the ground state. How do I know it's ground state? It's literally on the periodic table, not a trick. If it's on the periodic table, it's ground state. If I added energy to an electron and excited it and moved it to a higher energy level, the electrons have to move from where they are, one of them, to a higher energy level. So I could say 2, 3, 1. So one of the electrons from here jumped up to a higher energy level. What's important is the number of electrons stays the same. So 2 plus 4 is 6 electrons, and 2 plus 3 plus 1 is 6 electrons. So I cannot change the number of electrons. I just want to move one of them. Okay, so sodium, as another example, is 2-8-1. So if I want to move an electron to a higher energy level, here's one way to do it. So this is ground state because that's on the periodic table. And we have 8 plus 2 plus 1. We have 11 electrons. Okay, so I could do this 2, 7, 2. No matter how hard I look on the periodic table, I won't find this, but this is still 11 electrons, but this is excited state, not on the periodic table. So if I said, which one of these is an excited state, what you would have to do is look on the periodic table and find which one was not on the periodic table. It would be this one. And if I said, what element is that? Well, that's what I need to add up the electrons. This would be 6 electrons. This one has 8 electrons. And then I look at the periodic table. What element has 8 protons to balance those electrons? It's oxygen. And so that would be the element. Okay, so again, ground state on the periodic table, excited state, an electron jumps up to a higher energy level. Okay, and that's it. That's ground state and excited state.